Good afternoon, everybody. I'm sure you're here for the same reason that I'm here, because we all want to build a new Web 3. And basically, over the course of this talk, I really want to communicate two core ideas. One is a metaphor for what is Web 3, just so we can kind of have a shared understanding. And then two, what we're doing at LIT, which is essentially a decentralized, programmable key network. So we'll start with the metaphor. So we sometimes talk on our team how Web 3 is like email. And basically, just to unpack this a little bit, the beautiful thing about email, as you all know, email is a protocol. Michael may use Proton Mail, I may use Gmail, and you might use Microsoft Office Mail, but we can all communicate with one another independent of the application we're using because we're all using the same underlying protocols. And in my view, that's what we're up to in Web3 in a general sense, is making the entirety of the internet work in this way. And so what I'm going to be covering over the next couple minutes is some of the tooling that we've built in pursuit of this specific mission. But before we get there, first let's talk about where we're at today as it relates to Web 2. So this is a highly generalized graphic, but functionally, you have an individual that's interfacing with a bunch of platforms, and then there's a big pool of shared data and money that the individual has no kind of contact with. This is our third-party identities and avatars and archetypes that are owned by the Facebooks and all the marketing tech platforms of the world. And so we'll kind of keep that in mind when we talk about functionally what is a key, and we're going to define a key such that we can define what is a key management network. But in asymmetric cryptography, a key basically does two core functionalities, which is the ability to do encryption and the ability to sign. And so when you pair the capacity to sign with decentralized state machines, such as storage networks and blockchains, basically what we're talking about are very fundamental computing capabilities, the ability to read and the ability to do writes to these networks. And so now that we have a sense of what a key can do, in the very generalized definition of Web 3, we have the key as the method of interaction into these networks, which are these state machines, whether they're databases, ledgers, things like IPFS, Ethereum, Gnosis Chain, so on and so forth. And so what we're doing at LIT specifically is turning the key itself into an application development platform with a distributed custody key management network. And so now we'll take a look at that same graphic with some more key types. And so also take a moment here to talk about what the security model is with LIT. So the key for the user, for some specific use case, is initially generated through a process called a distributed key generation, which is the network of the nodes come together and they create a new secret, a new ECDSA curve, the signing algorithm that lets you communicate with a lot of these networks like Bitcoin and Ethereum. And then, so that's layer one, which is the key never exists fully in its entirety. It only exists as secret shares stored across the LIT network. The second layer is for each node within the network. That key is stored inside of a secure enclave, specifically secure encrypted virtualization. We've done a direct bare metal integration with AMD's chips. And so that is that node's individual private secret, and they are attesting to the fact that all of the operations that are taking place on their node, as well as their own little private secret, which is that secret share, cannot be contacted based on this secure enclave technology. And then the third level of security, at least initially, can you all hear me all right? I'll just kind of hold this. Yeah, the third level of security is that, at least initially, all of the node operators are named parties. So it's a federated network of named operators, and that federated network essentially functions as a DAO, selecting and deciding who is going to be joining and leaving the network, essentially stewarding kind of the internet's root key, if you want to think about it as like as a metaphor. And so the initial product that we rolled out in January was something that we were calling decentralized access control. And this was a method where somebody can, and still today, encrypt something client-side. Let's just say it's a video, for example, of a wonderful talk given at Infracon Day, and they can encrypt that client side and upload that to some public or non-public storage, whether it's IPFS, a blockchain, S3 from Amazon. And as a result of doing that client-side encryption, they generate a symmetric key. That symmetric key is associated with that data. That's the thing that decrypts it. And then they can go to Lit and they say, hey, I'm going to encrypt this key to your network, and please provision this key based on a set of rules. So a very simple way to think about this is token gating, where it says like anybody who owns the Infracon Day POAP can decrypt the video from Infracon Day and view it. And so let's say Alice is taking the video. Alice encrypts that video and sets the rules such that only the owners of the Infracon NFT can decrypt that video. Bob shows up later. He owns that NFT. He signs a message. His message is broadcast to the nodes of the Lit network, which are kind of represented in the middle there. Each of those nodes makes a call down to the blockchain, essentially thinking about the blockchain itself or the public data as the public access control list. And it is our intention to integrate Pocket Network there to further decentralize that communication. And then each node, using its share of the underlying network secret, creates what's called a decryption share. But you can think about it kind of like it's just an authorization. And that node sends its decryption share to the user who's collecting them in the client, to Bob, this decrypting party. And so an interesting mental model is to think about how like torrents work. You know, if you use BitTorrent, you're essentially collecting pieces of content from a bunch of different parties. Here you're collecting bits of an authorization from a bunch of different parties. And once you've collected a threshold of them, what you get, you know, in the torrent world, you have the movie. In this world, what you have is the capacity to sign something or to decrypt something. In this case, what you're decrypting is that symmetric key associated with the video, pulling it down from IPFS or wherever, and then watching it. And so we've seen several hundred applications integrate this for a number of pretty interesting use cases, largely where they're storing private permission data on the open web, from social things like token-gated chat to things around intellectual property, whether it's token-gated video like we've talked about just a moment ago. And then probably most interestingly and closest to the frontier is around authorization and what the notion of consent and decryption rights looks like from the context of one login for the entire internet. I'm sure a lot of you have logged into a website with Google and reach the consent screen where that website says, we want access to your contacts and calendar, and then there's a consent flow associated with that. There's a handful of teams that are starting to think about what that flow looks like, entirely built with decentralized architecture, so that that agreement and that relationship between the user and the application around the use and viewing of their data is something that doesn't have Google as the data custodian involved in, and is more of a first-party relationship between the application and that individual. Awesome. Now moving on to what we just announced about a week and a half ago, which we've been calling decentralized cloud signing. You could think about this also as programmatic signing. It's the exact same threshold-based structure, but here it's less around conveying decryption rights and more around automating rights, like WRITES, to state machines. And so the way that this system works is functionally what we're doing is taking a key and having it held in distributed custody and represented or owned by one specific user. The current kind of authorization model is the cloud key has an ownership NFT, but we've seen people hooking up like Discord as an auth method or Apple Passkey as an auth method. So we're starting to get to the world where like your face can function as your private key because the key is living in the cloud as we start to think about account abstraction and bringing the next billion people into this ecosystem. And then that key itself, that cloud key, is an application development platform. And the way it works is the owner of that key can consent to some code to sign on their behalf. And the way that that works structurally is somebody writes some JavaScript and uploads it to a specific content ID on IPFS. And then when they whoever, whether it's event triggered, user triggered, application developer triggered, basically says, hey, please run this program at this specific content ID. It's the same process that we talked about earlier, where the nodes each individually read from that public data store. And what they do is, in this case, we've connected something called Deno, which is a JavaScript runtime environment, to the nodes. Each of the individual nodes runs that computation and produces a signature share in this case, which again is like the authorization to sign, whereas we were talking about the authorization to decrypt earlier. And then it's the same kind of system where some party, whether it's the user or some kind of executor network, and we can talk more about that, collects those shares, those signature shares, or those authorizations, and once they've collected 2/3 of them, they can push a transaction to chain or do a write to IPFS or Ceramic. And so this whole frame of thinking about the key as an application development platform opens up an enormous kind of field of creativity, and I've been really excited about continuing to talk about that with some of you, and that's been a topic of a lot of conversations today. But just to ground it in a couple examples, like for DeFi, for example, currently there's really no way to do like a limit order in DeFi. If you have some staked tokens, the state of the art is you sign up for some DeFi alerting service, and if the price starts to drop, you get a text in the middle of the night, and you rush over to your ledger, and you're pushing a button such that you can unstake your tokens. But in a kind of cloud key paradigm, or like a decentralized KMS plus serverless function paradigm, you could have a function that says, when you see the price of XYZ token drop more than 10% in a 2-hour period, execute the following program that unstakes the tokens, sells it for USDC on a DEX, and sends it to my ledger. So that's like a pretty fun DeFi use case. We can also start to think about it in the context, as I mentioned earlier, of account abstraction and what it looks like potentially for mobile gaming for each new user who uses a mobile game to bake one of these cloud keys into the game. And so like an interesting example here, frankly very similar to the DeFi thing, but if you're playing some decentralized MMORPG and you have a bunch of carrots in your inventory and you want to set it up such that you put your carrots for sale when they reach a certain price, that starts to get really interesting too. And this kind of automation and privacy piece, like even though I'm presenting them on 2 separate slides, you can totally kind of use them together. You could also bring that in and start to have like asymmetric information in mobile games and in blockchain games with the encryption piece as well. And then, again, related to account abstraction, we can start to think about what like biometric authorization looks like, essentially scanning your face and having a PIN code as the authorization method for using your wallet and adding these automations to it. Some of the other things that I think are really, really exciting about this whole notion of we call them PKPs, programmable key pairs, is one is around like liquid staking and the staking receipts. So we don't have this live on the mainnet yet, but if this was live prior to the merge, you could have imagined a world where people staked to the chain formerly known as ETH2 from one of these cloud wallets, and then that wallet itself, the private key, is liquid because the private key for the cloud wallet is never known. In fact, it never exists. It's generated through this DKG process and has an owner that is an owner of an NFT. And so this is funny because there's been like this big debate around soul-bound tokens and verifiable credentials. This functionally breaks the notion of a soul-bound token because it makes a private key something that it itself is liquid, which has some pretty interesting implications, I think. And then the other thing that's really cool here about this kind of aspect is that the initial curve that we chose to decentralize is kind of the Bitcoin curve, ECDSA. So it's compatible with the likes of Cosmos and Ethereum and all of the EVM chains, as well as Bitcoin. And so there's nobody working on this yet, but this would be an excellent, excellent method for doing wrapped Bitcoin inside of all of the EVM ecosystems using this methodology for it, whether it's Bitcoin itself or some of like the rare Pepes over there on that chain. So that's PKPs. And then, I I wanted to save some time for questions, but I know we're kind of moving fast. But I just wanted to kind of end on a final thought. And this is something that we've been thinking a lot about, which is kind of decentralized microservices as the frontier. There's been this idea around that there's fat protocols and thin apps for a while. But really what we're starting to see emerge is a level that exists in between them. So whether you're looking for something to build or if you have a protocol, this is the conversation that myself and the folks on our team would absolutely love to have with you, which is what is an opinionated product or service that potentially combines multiple underlying protocols, potentially has UI components associated with that developers can start dropping in, whether it's for social, whether it's for chat, whether it's for DeFi automation. And these are things like SDKs with UI components associated with them that are combining the likes of, Ceramic and Lit, for example, or Gnosis Chain and Lit. And this is really where we're really excited. So if you're starting to think about what do these services look like I was just talking with Eric from LivePeer, and we've got some awesome opportunities to make services that are token-gated, decentralized videos, thinking about what it looks like to have drop-in stories for Web3 social that are totally decentralized and just ready to go for developers. So if this is something that you're interested in, please come find me. I would love to talk to you about that. And if you want to learn more, we're all over the web. That's me. Please DM me if we don't run into me today. And the docs you can also find there. They're just developer.litprotocol.com. And with that, I'll kind of come back to the central idea that the main goal here is how can we make it easier to enable application developers to build the decentralized web. It's not going to just be one team. This is absolutely a group effort, so to speak. And I'm so grateful for the Pocket team for inviting me here and creating this space. Thank you so much.